let's start with the definition of the derivative. The derivative of f at x, written f prime of x, is defined as the limit, as h goes to 0, of the quantity f of x plus h minus f of x divided by h. This limit represents the instantaneous rate of change of the function, and geometrically it is the slope of the tangent line to the curve at that point. Now for the basic rules that make differentiation quick in practice. First, the constant rule. The derivative of k, where k is just a constant number, equals 0. Next, the power rule. The derivative of x to the n equals n times x to the n minus 1. The sum rule says the derivative of f plus g equals f prime plus g prime. Derivatives distribute term by term across addition. The constant multiple rule says the derivative of k times f equals k times f prime. Constants just get carried along for the ride. The product rule says the derivative of f times g equals f prime times g plus f times g prime. Notice this is not simply f prime times g prime. And the quotient rule says the derivative of f divided by g equals the quantity f prime times g minus f times g prime, all divided by g squared. Now let's put the limit definition to work with a worked example. Differentiate f of x equals x cubed using the limit definition directly, and then check the answer against the power rule. First, we expand f of x plus h, that is x plus h cubed, which equals x cubed plus 3x squared h plus 3xh squared plus h cubed. Next, we subtract f of x, which is just x cubed, from this expansion. The x cubed terms cancel, leaving us with 3x squared h plus 3xh squared plus h cubed. Now we divide every term by h. Each term has at least one factor of h, so this simplifies neatly to 3x squared plus 3xh plus h squared. Finally, we take the limit as h approaches 0. The terms containing h vanish, leaving just 3x squared. Let's check this against the power rule. The derivative of x cubed using n equals 3 gives 3 times x to the 3 minus 1, which is 3x squared. This matches exactly what we got from the limit definition. Here is a useful trick for products of more than two functions. Rather than trying to hold every single term in your head at once, apply the product rule pairwise. Treat one pair of functions as a single block first. Differentiate that block against the remaining factor, and then expand out the inner pair afterward. Now the single most common product rule error to watch for, writing the derivative of f times g as simply f prime times g prime. That is wrong. The correct form is f prime times g plus f times g prime. This mistake happens because the sum rule really does distribute term by term, so learners wrongly assume products behave the same way. But a product is not a sum, and it does not distribute like one. Finally, here is a teaching tip to lock in the correct order. Before you write the product rule down, say this fixed phrase out loud every single time. First times derivative of second plus second times derivative of first. Always in that same left to right order so the sequence never gets scrambled.